In this video, I will show you how to configure STUB and totally stubby OSPF areas on the Nokia 7750 SR. Sometimes it's not necessary to flood external routing information into an area. A small branch office is an example. In such cases, the area can be configured as a STUB area. A STUB area is an area that does not allow external OSPF route advertisement into the area. Routers within a STUB area only have default route to the ABR. This reduces the size of the OSPF database, which in turn reduces memory and CPU usage for route calculations. Router 6 is an ASBR generating external LSAs, type 4 and type 5. These are flooded within the OSPF domain. Router 4 is the ABR connecting area 3 to the backbone area. Hence, there's no need flooding external LSAs into area 3. In this lab, we will configure area 3 as a STUB area and examine the difference in the OSPF database. Also, because there's only one exit point from area 3, the summary LSAs are also not useful in a STUB area. To have the ABR router 4 filter summary LSAs, we will also configure area 3 as a totally stubby area and examine the difference in the OSPF database. Let's go to the CLI and begin. I've broken down the required steps into 16 separate steps. Sounds like a lot, but they're not. Most of these steps listed here are just reachability tests, as you will find out. I will, however, take you through each one for clarifications. So the first step is on router 8, which is the router within the area 3. We are going to perform some reachability test using the ping. On router 4, which is the ABR connecting area 3 to the backbone, we are also going to check the OSPF database. We then go back to router 8, check the OSPF database. This is very important because we will then use this to compare after we've applied the configuration that we are about to. So again, step 4 stays on router 8, we check the neighborship with the ABR. On router 4, do the same thing. 6 says on router 4, we configure the area 3 as a STUB area. Now, this is the first configuration that we are going to apply, because as you can see, the previous steps are just verification checks. So like I said, it looks like a lot, but really it is a very simple step. On router 4, we then check the OSPF neighbor pairing. On router 8, again, we check we configure the STUB area. This is the second configuration that we're applying today. So the first one was on router 4, which is the ABR. The second one is on router 8, which is the router within area 3. We then go on to the router 8 again and check the neighbor pairing with the ABR. On router 4, we check the OSPF database. We expect something to have changed here. I will highlight it when we get there. On router 8 again, we check the OSPF database. Also, something must have changed here. I will highlight that also when we get there. We then perform our reachability test, because at this point, we have configured the area 3 as a STUB area. So we want to make sure that we can still reach all the areas within our OSPF domain. Once that's confirmed, we then move on to configure the area 3 as a totally stubby area, right? And then we again run the same checks that we did previously. We check the OSPF database. A lot must have changed in here as well. We then check it both on the ABR and on the router within area 3. Again, we then finished with the reachability test. So on router 8, let's check the reachability to router 6, which is the furthest from area 3. So we're going to ping the system interface of router 6, which is 172.17.0.6. We can reach that. We then do the same thing for the ABR router 2 on the other side, which is .2. We can also reach that. And then we ping our nearest ABR, which is router 4. And that is 172.17.0.6. 19.0.4. So we can reach all these areas before we start our configuration. So let's go on to the next step. So the next step says we need to check the OSPF database on router 4 and router 8. So let's go to the ABR router 4, issue the show router OSPF database. As you can see, as expected, we've got loads of summary LSAs, and also we've got the external LSAs. These are being generated by router 6. As you can see, this is the IP address, the system IP address of router 6. It's generating the external LSAs because it's we're redistributing from different the connected interfaces into OSPF, so those are seen as an external LSA, type 4 and type 5. So let's go on to our next our router 8 and issue the same command, which is the show router OSPF database here as well. As you can see, as expected, we see those summary routes and external LSA types in here as well. So we then proceed with the next step, which says we need to check the OSPF neighbor pairing with router 4 on router 8. I will explain why we need to do this in a minute, but we do that with the show router OSPF neighbor. We've got the pairing to router 4 within area 3, which is what we were expecting to see. On router 4, we issue the same thing, show router OSPF neighbor. We should see more here, but what we're interested in is the one going to router 8 in area 3. So it's currently full on both sides. And then the next step says we then need to configure area 3 as a stub area on the ABR. So let's go on and do that. So on the ABR, we issue the configure router OSPF area 3, and all we need here is the keyword STUB, and that's it. This is the configuration. This is how you configure an area as a stub area, but it's not done here, and I'll go back and show you why it's not done. So if we exit all here and issue the show router OSPF neighbor command again, you'll notice that we've lost router 3. The reason for this is we need to go over to router 8. Sorry, we've lost router 8, not router 3. We've lost router 8 within area 3. This is because we've only configured one end as a stub. For this neighborship to pair up again, we need to do this command on both sides. So let's go on and fix that. So on router 8, if I also issue that command again, show OSPF neighbor, we've lost router 4 within area 3. So let's correct that. And to do that, we issue the configure router OSPF area 3 stub. And if we exit all here and show the router OSPF neighbor, we should have re-established our pairing with router 4, which we have. Let's go over to router 4 and just double check that as well. Yes, so we now have router 8 within area 3 in the full state once again. So what we then need to do is, so far we've only just configured router area 3 as a stub. So we need to make sure that we can still reach all those external endpoints that we were able to reach before. And also we want to check the OSPF database and see what has changed. So on router 4, let's issue the show router OSPF database again. So as you can see here, we now have a summary, a default summary entry here which is being generated by router 4, and it's sending it into area 3. This wasn't there before we configured this area 3 as a stub. As you can see, the previous show command does not have that default route. The reason this has appeared is because we've now configured area 3 as a stub, and the ABR is going to generate a default route into area 3 for the routers within area 3 to use. So let's go over to area 3, like I said. Let's go over to router 8, which is in area 3, and check what has changed in the database. So show router OSPF database. Again, as you can see, we now have a summary route, a default summary route, which is being generated by the ABR router 4. So we then move on and ping to make sure we can still reach the external endpoints that we were able to reach earlier. So we usually ping, we're going to ping router 6 172.17.0.6. We're still able to ping router 6. We're going to ping the far end ABR router 2. We can still reach router 2. Obviously, we can still reach the ABR, the nearest one as well, which is the router 4. So we're still able to reach all the endpoints that we were previously before we applied the configuration, which shows that really reachability wise we are okay. So one more command here. Let's see what's in the root table. Because this will be useful after we've applied the next configuration. As you can see, we now have a default route which has appeared, and it's been generated from by the OSPF. So what we've done so far, let's recap before we move on to the last section. So we've configured area 3 as a stub area. We've verified that we can reach the endpoints that we were able to reach earlier. So what we want to do next is we're going to configure area 3 as a totally stubby area. And to do that, all we need to do is add the no summaries keyword. So let's go on and do that. And by the way, you only need this command on the ABR connecting to the stub area. You don't need it on the routers within the area. So don't forget that. You only need this command on the ABR connecting into the stub area. In our case, this will be router 4. So let's go to router 4 and issue our configure router OSPF area 3 stub, but this time no summaries. This is the difference. This is what makes the area a totally stubby area. Please don't forget that. The stub command itself makes it just a stub, but if you don't want summaries to also be sent into that area, you need to add the no summaries keyword into the command. So we hit return on that. Let's admin save this, and then we go over to router 8. We don't need to do anything here. We just need to verify to make sure what we've done is in effect. So first thing we want to do is check the OSPF database. As you can see, the database has shrunk considerably. The only summary route that we have is the one being generated by the ABR, and it's for the default route. All the other summary routes are being removed or filtered, if you like. So if we go back to our previous command, all these summary LSAs that was being generated before by all the other ABRs are now being filtered. Yeah, so once you configure an area as a totally stubby area, all the summary LSAs also are filtered. So again, I issued this command for us to check the routing table as well. So let's see what's changed in the routing table because this is the whole idea why we are applying this. Show router OSPF. Actually, show router route table. And look at that. Can you see how effective configuring an area as a totally stubby area is? Previously, as a stub, you still have all the other entries being generated by OSPF or being sent into this area by the OSPF. You really don't need this in a totally stubby area. You can still reach everywhere. All you need, really, all the routers within the stub or totally stubby area need is a default route. So to prove that, we will still run our reachability test, even though our routing table has shrunk considerably. So let's ping the far end, which is router 6. 172.17.0.6. We can still reach router 6. Let's ping the far end ABR router 2. We can still ping router 2. Let's ping our own ABR router 4. And as you'll expect, yes, we should still be able to ping router 4 as well. As you can see, we are able to. So in conclusion, configuring an area as a stub is okay. I mean, it depends on what you really need to achieve with your design. But if you really want that area, say for instance, you have a branch office with a small or low end router, you don't really need the full OSPF routing table being sent into that area for that router, because all this, they're processor intensive, if you like. So the best way to do it will be to configure the area as a totally stubby area, which will reduce or filter all the unnecessary summary LSAs being sent into that area. The only required summary LSA will be the one being sent by the ABR for a default route. And that's all a totally stubby area needs. It will still be able to reach everywhere within your network, but the processor and the memory usage on that router will be greatly reduced. I hope you find this video helpful, and thank you for watching.